Welcome everybody, my name is Brian McLogan, and in this video I want to help you factor. And we are going to be working on factoring trinomials when a is equal to 1. And what I mean by a is equal to 1, that our coefficient of our quadratic term, ax squared plus bx plus c, that a is going to be 1. So you can see in all these examples, and I have 73 of them, we're always going to be dealing with x squareds. Now, that's one important thing that I want you to know before we get started. The other important thing I want you to know is what exactly does factoring mean? Now, there's a lot of different ways we can, factor expressions. And in this example, we're factoring quadratic expressions, and we're focusing on trinomials and sprinkling in some binomials here and there. But the main idea, factoring is to rewrite as a product. Now, this is something that is very important in that we'll be using in a skill that we'll be using a lot in our math classes, but the important thing is rewriting as a product. So you can see that in all of these expressions that we have here, there's between each of these terms is addition or subtraction. So we want to rewrite it as a product. And the quickest, easiest way I can represent this for you is, or at least what we need to remember is, how would I rewrite these as a product? So we need to go back just before we get to the factoring. I'm going to kind of cover this really quickly. In case this is a review for you, you can kind of skip ahead to the factoring part. But for those of you that are still a little iffy on the factoring, it's really important that you understand what exactly we're looking for in all of these problems, because I'm not going to break down all of these problems very slowly. I am going to work through these rather quickly. So therefore you can start gaining the skills and the kind of patterns that's going on with factoring this many problems. The main important thing that I want you to recognize is what happens when we multiply binomials times each other. And this was a skill that we practiced before we get into factoring in our earlier mathematics classes. And we talked about distributive property, and to help remember us, sometimes you guys might be familiar with FOIL. And basically that we just multiply every term by every single other term. And what happens when we do that is we get, in this case, we get x squared. 1x times 2 is going to be 2x, 1 times x is going to be a positive x, and 1 times 2 is a positive 2. And what's really important by multiplying these two binomials is we notice that the middle terms are like terms, so therefore we can combine them. And we can actually simplify this now to a trinomial. So when we multiply two binomials, they create, or at least these two types of two linear binomials, they create this quadratic trinomial. And what's important about this is, again, these are binomials that are broken up by multiplication. That is, so if we want it, the process of going from here to here is just called factoring. That's what we're trying to do. We're trying to take our trinomial and rewrite it as a product of two binomials. So for all of these problems, you can see that they all can represent that understanding you're going to be able to use. Our factors are going to be all the same for all of these examples. All right, so you're not going to have to, kind of guess and think, where do we kind of start? They're all going to start at the same point. So since a is equal to 1, then all of our problems can all start with this basic understanding. We can factor the trinomial into two binomials, and the first two terms of those two binomials are going to be x, right? Because you notice it's all x squared, not y squared or anything. But again, x times x, when you multiply those first two terms, is going to give you x squared. Again, look at all the problems that we're going to be doing. They're all x squared. So that's a nice first thing to kind of notice when you have a problem, any random problem to factor. If you notice that it's a quadratic trinomial and a is equal to 1, then you know that you're starting off with this product of two binomials. Now, all of these problems are all going to be factorable across real rational numbers. So you're not going to have to worry about, something being non-factorable across real rational numbers. We're going to keep everything fairly basic today. All right, so for all these problems, we're going to start with this, right? This is what we're going to start with. And basically from here, we just are going to ask ourselves two questions. What two numbers multiply to give you our last term, right? 1 times 2. What two numbers multiply to give us 2, but then combine to give us that middle term? So you can think of the factors of 1 as positive 1 and positive 1. Well, 1 plus 1 gives us positive 2. And we notice that our middle term, that combine, that's a negative 2. So then we think, well, what if we did negative 1 times negative 1? That would still multiply to give us a positive 1, right? But now when I combine them, negative 1x plus negative 1x gives you negative 2x. And you can see how that works out. So this example, if you don't already notice what's special about this example, let's just set it up from what we know, right? We know that it is a quadratic trinomial with x is equal to 1. So I set this up and I say, what two numbers multiply to give me 2, add to give me positive 3, and then I'm like, oh, silly, this is the problem that I just did. So therefore, I can quickly go ahead and add in the answers for this one. All right, so not everything's going to be that easy, but I want you guys to recognize at least these first characteristics for all of these, because that's going to allow us to do this worksheet rather simple. And when you have a factoring problem that, that you're exposed to, that's one thing a characteristic you want to look for. You want to look for it's a quadratic trinomial, and you want to look for a is equal to 1. Therefore, then you can apply these same characteristics. And obviously, for all the other types of factoring problems, we'll be getting into those on a different video. All right, so the next one here is I'm basically asking myself what two numbers multiply to give me negative 3, but then add to give me a positive 2. So again, we are limited on our factors, right? We have 3 and 1. The main thing, guys, is when your middle term is going to be positive, that means the larger of my two factors has to be positive, right? So therefore, on my two factors for negative 3 is positive 3, negative 1, and negative 3, positive 1. Well, since the larger factor needs to be positive, I know that this is going to give me a 3 and a x minus 1, okay? And again, always, once I start kind of picking this up, which I'm going to here rather quickly, once I start picking this up, you can always just check my work. Check the middle and the outside terms. And if those don't combine to give me my middle term, then obviously, I made a mistake or you made a mistake, depending on what it is. Also, this is the factored form, just a real quick. If you want to write these in a condensed form, like an x minus 1 squared, since they are repeating, you can go ahead and do that as well. All right. Here I'm looking at negative 4. So obviously negative 4 has a couple of factors, right? It's negative 4. You could be 4 and 1 or 2 and 2. However, I need to think about what two numbers, which of those factors are going to add to give me a negative 3. Again, notice that this is negative. So therefore, the larger of the two factors has to be negative. So therefore, I think, well, the larger of the two factors between 4 and 1 is 4. So that should be a negative 4 and a positive 1. And so I just write this out as x minus 4 and x plus 1. Boom. All right, ladies and gentlemen, I'm going to quickly go through this last one here because this is a binomial. And I'm going to quickly do the binomial, and then I'm going to start speeding through all these. All right, I just wanted to kind of give a little bit of an introduction of an instruction for those students that, kind of need that little help as far as where I'm getting these answers, because I'm going to start going through these problems and I'm still going to talk my way through it. I'm just going to do a lot of it in my head. So, this is something that you can follow along with me. Now, this expression can also be rewritten as x squared minus 0x minus 4. We don't really write it like this, just because obviously 0x, guys, is just 0, and so it's just redundant. But I'm writing it like this so you can understand that there is a middle term. It's just 0. So you got to think, what two numbers multiply to give me negative 4 but add to give me 0? Well, kind of going back to our understanding here, negative 4 and 1, those have a difference of 3. Negative 2 and 2, or negative 2 and 2, when you combine those together, those are obviously going to have, those are actually going to go to 0. So you can see this is also the difference of two squares, a special factoring technique, if you recall that. So whenever we look at binomials, at least in this factoring worksheet, we're going to be thinking of difference of two squares, meaning factors that are going to be exactly the same because we want them to add to 0. All right, so now, guys, I kind of went through the quickness of that. Now what I'm basically going to do is just kind of talk about the dot and the plus. So the dot is going to be what's going to multiply, and then the plus is going to be really what I'm trying to combine or add together, even though I don't really like using a negative symbol there because I'm trying to add them to give me a negative number. But that's what I'm going to be doing in my brain as I work through these. All right, what two numbers multiply to give me negative 5, add to give me negative 4? So I'm thinking that's going to be a negative 5 and a x plus 1. Now, I'm going to be doing a lot of these problems, so if I make a mistake, I apologize. Please just call me out on it in the comments, and I'll make sure I pin you down below. What two numbers multiply to give me 6, add to give me 7? So that's going to be x plus 6 and x plus 1. If it was 3 and 2, then my middle term would have been 5x. What two numbers multiply to give me 8 and add to give me 6? Well, obviously, we only have two options, x plus 4 and x plus 2. So a couple quick little things I want you to notice here, guys, is when we have the last terms positive and my middle terms positive, I know my two factors have to be positive. Positive, positive, my factors are positive. If my last term is positive and my middle term's negative, like where was that? Here, then I know my two factors are negative. If my last term is negative, notice how one factor is positive, one factor is negative, right? So therefore, in your brain, when you're doing these, you're actually trying to think of the difference. And that's what sometimes is hard for people to do in their brain. You're trying to think of one positive number you're trying to do subtraction in your brain. However, this next example, it's positive, middle term's negative. That means my two factors are both going to be negative. To add to give me -5, that's going to be x minus 3 times x minus 2. So negative here, now I'm trying to find the difference of my factors. So the difference of the factors is 7, that give me 6. Well, that should be 7 and 1, right? And since the middle term is positive, right, I'm trying to multiply to give me -7, so that should be a x plus 7, x minus 1. Again, I want my larger of my two factors to be the same power as my middle term. Let's see, they're negative, so now I find the difference of my two factors of 8 to give me 7. That should be x minus 8. And then x plus 1. Here's positive and negative. That means both factors are going to be negative. So that should be an x minus 9 and x minus 1. And again, those add up to give me -10. Now this is negative and that's positive, so I'm looking for a difference. So what two numbers multiply to give me -10 but add to give me -9? That should be an x minus 10 times an x plus 1. What two numbers multiply to give me 12, add to give me -13? Positive, negative, so therefore that's a positive negative, so that should be an x plus 12. No, sorry, that should be minus, right? If the middle term's negative, that means both factors are negative if the last term's positive. So x minus 1 times the x minus 12. Here, x squared minus 9. 9 is a square number, so therefore I'm going to use the difference of two squares. And again, guys, if you were to multiply this out, you would notice that the middle terms add to 0. Let's see, that's last term is positive. That means, and my middle term's negative, so both factors must be negative. So what two numbers multiply to give me 10, add to give me -7, so that's going to be x minus 5, x minus 2. Positive, negative again, so again, two negative factors. Let's see, that's going to be x minus 11 times x minus 1. Negative and a positive, so therefore, again, now I'm looking for the difference of my two factors, where the larger factor has to be positive, as well as the difference between the two factors has to be 1. So 12 is not a fun number to do, right? Because you have 12 and 1, 6 and 2, 4 and 3. But the difference of when I add and subtract, when I subtract my factors from each other, the only two factors that have a difference of 1 is 4 and 3. If I was looking for a difference of 4, I would do 6 and 2. If my middle term was 11, I would think of the factors 12 and 1. So these are some of the kind of tricks that I want you to start recognizing as you're doing these problems. But we're only 18 into 73, so let's get going. Again, the larger factor, since my middle term is positive, needs to be positive, so that's going to be 4 and 3. Here's 12, but now we have a difference of -4, so therefore the larger factor needs to be negative. And again, if I'm looking for a difference of 4, I'm looking at 6 and 2. So x minus 6 times x plus 2. Here's 2, so it's a positive, negative, so both factors are negative. So therefore, I should do x minus 2, x minus 1. Here's 3, positive, positive. That means they should both be positive. X plus 3, x plus 1. Positive, negative, so that'd be x minus 4, x minus 1. Positive, positive. X plus 5, x plus 1. Negative, negative, so therefore two factors have a difference. So remember, the factors of 6 are 6 and 1 and 3 and 2, right? So if the middle term was 5, I would look at the factors 6 and 1. Since the middle term is 1, then it's obviously the two factors are 3 and 2. Since my middle term is negative, the larger of those two factors has to be negative. So that means the 3 needs to be negative. And again, all of these problems, if you're a little bit confused or I'm going too fast, multiply them out. Go back to the original thing and multiply them out, and you'll be able to see this. All right, the next one here, difference of two squares, right? Square number, so therefore we can use x minus 1, x plus 1. Now here's another thing. You can see that positive, positive. So therefore, what two numbers multiply to give you 4, add to give you 4? Well, that's going to be x plus 2 and x plus 2. Now, this is also called a perfect square trinomial. So there's another trick that you can do to determine if this is a perfect square trinomial, like our first example. All right. So if you have a square term in the front, which is 1, and a square term there, x squared, right? And your middle term is double the square root of that term, then it is a perfect square trinomial. So the square root of 1 is 1, times 2, doubling it, is 2. And you can see my middle term is that way. So therefore, it is a perfect square trinomial. Since that middle term is negative, then both factors are negative. Let's use that understanding over here. So square root of 4 is 2. 2 times 2, or doubling 2, is 4. That's my middle term. Since my middle term here is positive, my both factors are positive. And you can see how that works. All right, in this case, we have a negative positive. So I'm looking for the difference of two factors. That's going to be 5. That's going to be 6 and 1. A larger factor has to be positive, which is 6. Here, positive, positive. So therefore, I'm just adding the two positive factors. Okay, positive, negative. Then I'm adding the two factors. So that's going to be x minus 8 and a x minus 1. Positive, positive. So I'm adding my two positive factors. Positive, positive. Again, adding the two factors. Hopefully you start to get this kind of pretty good. Right? And again, I'm just figuring out the factors in my head because there's only so many of them, right? I mean, 10, you only have 5 and 2 and 10 and 1. 9, you have only 3 and 3 and 9 and 1. 8, you have 8 and 1, 4 and 2, right? There's only so many. So we're keeping this rather simple. And I understand when you're doing more difficult factoring problems, you might want to use a factor tree or whatever else to, kind of list all of the factors. But, that's not the purpose in this video. The purpose in this video is for you to start seeing the relationships of our factoring our expressions. And I think once you understand that, then it's a little bit easier to branch off to more difficult factoring problems. All right, so in this case, we have 12. So we're looking for the sum of my two factors. That's going to give me 8. So again, we have 4 and 3. That gives me 7. Nope. 6 and 2, which gives me 8, right? The other sum would be 12 and 1, which gives me 13. So this is going to be an x plus 6 and an x plus 2. 11 and the sum is 12. Well, obviously that's going to be plus 11 and x plus 1. Here, I recognize this is a difference of two squares, right? That's a square number. That's a square number. Okay. Square root of 9 is 6. I'm sorry. Square root of 9 is 3. 3 times 2 is 6, right? Since it's negative, then I can just rewrite this as an x minus 3 squared. All right. This is going to be a negative, so we're looking for a difference of factors, which is 2. Larger factor is going to be negative, so that means x minus 4, x plus 2. We're looking for a difference with a difference of factors, which is 3. This one sometimes gets confusing, but remember 5 and 2, those multiply to give you 10, and they have a difference of 3, and the larger factor has to be negative. So x minus 5 and x plus 3. All right, next one we have x squared minus 7x plus 12. So factor, that's a sum, and they both need to be negative. So x minus 5 times x minus 2. Sum and sum, you could also recognize this as a product of a perfect square trinomial. Difference and 1 is positive, so therefore that's going to be x plus 2 times x minus 1. Right? So, and then this next one is we're looking for a difference, and that difference needs to be 11, so that'd be x minus 12 and x plus 1. All right, guys, almost more than halfway done. So let's kind of wrap this up. And again, when I'm saying this, I'm looking at this last term. When I'm saying sum or difference, I'm looking at the negative. If I see this as negative, then I'm thinking of the two factors that they need to find the difference between the two factors, and then I look at the middle term. And if the middle term's negative, that means the larger of the two factors has to be negative. So I say negative 3, so I'm looking at the difference of two factors of 3. One of them has to be negative, right? Remember that last term is negative, then one factor is positive, one factor is negative. Since my middle term is negative, that means the larger of the two factors is negative, so that's going to be an x minus 3 times an x plus 1. Okay? Again, now we're looking at a difference and positive. So therefore, I'm looking for the difference of my two factors, where the larger factor now has to be positive. So I think of x plus 4 times x minus 1. Difference and positive, so therefore x plus 5, x minus 1. Difference and negative, x minus 6 times x plus 1. Okay, now we have a sum and positive, so now I'm thinking of adding the two factors, and since my middle term is positive, both the factors are positive. So what are the sum of factors of 6 that give me 5? Well, that's 3 and 2. So x plus 3, x plus 2. sum is negative. Now again, we know that both factors, now we're looking for the sum, but since my middle term is negative, we're looking to two factors that are exactly the same, that are, when we combine them together gives you that middle term, and they have to both be negative, which you could also recognize this as a perfect square trinomial relationship. All right, here's another sum and negative. So sum and negative, so they're both going to be adding up to give me a negative, so that'd be x minus 7 times x minus 1. The difference and positive, no, that's not right, yeah. Okay, difference and negative, so this would be x minus 9. Difference and positive. Let's see, this is going to be a difference and positive. This is going to be a, now my brain is starting to get to there. This is going to be a difference and negative. It's x minus 11, x plus 1. This is where you start making mistakes. This is a sum and negative. Hope I don't make a mistake. This I recognize as that perfect square trinomial relationship, right? Square root of 9 is 6. 6 times 2 is 3. You could also do the same factoring technique that I've been doing, but we want to recognize those special relationships as much as we can. This is going to be a difference and negative, so this is going to be a sum and positive. This is going to be a sum and negative. This is going to be a difference and positive. Positive. That means the larger product is going to be positive. This is going to be a difference and positive, so therefore x minus 12, x plus 1. This is going to be a difference, so I'm thinking the difference of two factors, and the larger term is negative, so that'd be x minus 7 times x plus 1. This is going to be a sum and negative, so both factors. This is going to be a difference and negative, so therefore x minus 2. This is going to be a sum and positive, so that'd be x plus 8. Difference and positive, so x plus 5. X minus 2. This is going to be a sum and positive, so x plus 4. X plus 3. This is going to be a sum and negative, so x sum and negative, so x minus 10. You can see my brain is like working a little bit harder now. It's doing some of these problems. You start to strain your brain and working through this. But hopefully at least you guys are kind of starting to pick up on some of these things that I'm going through. And again, I'm thinking about what two numbers multiply to give me negative 9, add to give me positive 8. So that's going to be an x plus 9 times an x minus 1. What two numbers multiply to 6, add to give me a negative 7. So that's going to be an x. That's not plus, it has to be a negative, right? Because you're doing a sum and negative. So x minus 6, x minus 1. Here, this is going to be a difference, and the larger factor has to be positive. So therefore, I'm thinking 6 and 2. Yeah. No. All right, this is going to be x plus 6 times x minus 2. Sum and positive, so that'd be x plus 4 times x plus 1. This is going to be a difference and positive, so x plus 3, x minus 2. Sum and positive, x plus 12. And this is going to be a sum and a negative. No, sum and negative. They both have to be negative. 2, x minus 5. There you go. All right, ladies and gentlemen, we are done. Hopefully that you were able to kind of follow along with me. You kind of understand. Hopefully I didn't make a mistake. It's very kind of mentally taxing to do this many problems, and I hope you never, for any reason, have to do this many problems in a row. But I really do believe if you work on this, this is an assignment that, I give my students, that if you work through this, if you work through these types of problems, then you will start to, kind of get that confidence in your factoring technique. So If you need more practice with this, or you'd like to try exactly to work through these problems, again, make sure you go ahead and download this worksheet in the description down below, and therefore go ahead and give it a shot. And whenever you need a little bit more of understanding of how to factor and which types of, what the answers are, I'll make sure that I provide the answers, for you, as well as this video to help explain and help explain your factoring technique. So I hope you enjoyed, and I hope you learned a little bit. I'll see you guys on the next one. Cheers.